So this question simply says that we have a small steel ball floating in a half-filled container of mercury. Mercury, if you remember from chemistry, is a fluid. So I have a fluid, and I have a small steel ball that floats in the mercury. Part of it's submerged, part of it's not submerged. Part that's submerged is what's going to provide the upward buoyancy force. When we add water, so we go in and we're going to add some water, we ask ourselves, what happens to the ball? Well, we know that steel will not float on water. Steel balls sink in water. And we know it's not going to sink to the bottom of the container because it can't go through. The density of the mercury is very high compared to the density of the steel. About 4 for this guy, and I think it's above 10 for the mercury. So there's mercury here and H2O up here now. And the steel has a density of about 4 grams per cubic centimeter. So the ball is not going to sink into the mercury. And the mercury is definitely not going to float on top of the ball or on top of the water. So the question we have is going to be, does the ball slightly rise or does it slightly sink? So if we think about this, the submerged volume, this area right there, the ball that was there was going to be our submerged object to begin with. Now we actually have 2 submerged. Our object submerged volume 2. So we have a second submerged volume. So this part right here is going to provide an upward buoyancy force. The bottom part, because of the mercury, is going to see an upward buoyancy force. So in the first case, we only have the upward buoyancy force from the mercury. In the second case, we have the upward buoyancy force from the mercury as well as the addition to the upward buoyancy force from the water. So the ball is going to slightly rise in this situation. So if we pour water in it, the ball will slightly go up because the mercury doesn't have to support all of it, since there is now some submerged liquid or some submerged volume in the water itself.